As a kid, when I played Battleship against my dad, I would never win because he had the unbeatable strategy, and until I caught on, it was impossible to defeat him. Now, 20 years later, I programmed that unbeatable strategy into your personal Battleship Aim Bot assistant. And so today we're going to get into the code, how it works, and the biggest secrets of it. And by the end of this video, if nothing else, you will never lose another game of Battleship. Before we begin, I just want to clarify that the game is programmed to win against classic game mode of Battleship. So we're playing with the ship lengths of 5, 4, 3, 3, and 2. And once you hit a ship, you must declare if it's been sunk and what ship was hit and or sunk. So our ships, here's our class. We're going to declare the name, the hit signature, which is just the first initial of the ship, the length of the ship, and then the hit chords array, the length of it needs to be the length of the ship. So our gameplay is going to immediately configure those ships, but you're also going to notice we're declaring a playing board and a targeting maps. Playing board is fairly simple. The playing board is just declaring a 10 by 10 two-dimensional array, and each character starts off as just a squiggly. Once it's been eliminated, we're switching to an O. If it's hit, it's going to switch to the hit signature of the ship. So targeting maps is where all the magic happens. This is sort of the brains of the whole program. This is how it gets so good at tracking down where your ships are at. So right off the bat, when a new targeting maps object is created, it's going to generate the targeting board and generate the targeting maps. The targeting board is just a 10 by 10 two-dimensional array where every other spot is going to be an X or an O, the X representing a valid spot to attempt to hit, and the O's it's going to ignore. So it's not going to try and fire on any of the O's. This is what it's going to look like with all of our coordinates, except the reds are X's, whites are O's. Now we have a 4-dimensional array. This is our map book. Okay, so what we're doing is making a list of valid maps to try whether or not we are targeting the smallest boat, one of the 3 lengths boat, the 4 length, or the 5 length carrier. And so just like our every other one that we're starting with, once the patrol boat, the smallest boat, is eliminated, we need to switch to every 3rd ship. This is how you clear the maximum amount of area as possible, is by eliminating what you don't need to hit. So our every third is going to be this map, every 4th is going to look like this, and every 5th, if somehow the carrier lasts till the end, is going to look like this. But we're not done yet because it could be more efficient. Depending on how your game plays out, it may be better to offset it by 1 or 2. And so our every 3rd is actually creating one for an offset of 1 and one for the second offset. So our 3rd has 3 options, but it could still be better because, once again, depending on the outcome, it may be even better to actually use the mirrored map. So for every single offset, we're also creating a mirror image. So we actually have 6 maps for our every 3rd, 8 maps for every 4th, and 10 maps for every 5. So this is how our map book is going to look. Our every 2 just has the mirror image, which is also happens to be the offset. Every 3 has 1 for each offset and the mirror. Every 4 looks just like this, and every 5 looks just like this. So how does this small function generate all of those maps? Well, we start off with a helper to help mirror and our charts needed list, because for every 2, we actually just need 2 maps, the first map and then its mirror or its offset. It's the same thing. Every 3, we need 1 for each offset, 1, 2, 3, and their mirrors. So it just doubles, same, 1, 2, 3, 4, and it doubles. And 5, 1, 2, 3, 4, 5, and the mirrors. So let's take a look at the first page of the map book, which is our charts for every 2. We know that it's 4 long, so it's going to run 4 times because we declared that it's 4 pages long. Of length charts needed, right? So we check the list, we're on our first page, so we just need 2 and 10 and 10. So this is the reason we have this list right here, is because we need to know how many total maps are needed. Once we've established that, we are going to go into our for loop of creating each offset, right? So because there is no offset, it's just a mirror, we're going to pretend that we are on every 3, right? So we're making these maps right here. We actually are only running at half the amount of times because we are going to simultaneously simultaneously make the offset and its mirror. So we have our first chart, which is going to be the first index of the array, or the 0th index rather. And then our chart is going to be 6 divided by 2, 3 plus the j that we're on. So in the first instance, it's going to be the 3rd index, or the 4th map. Now we can get started on our loop. This is for the rows and columns, so we need to immediately go 2 deep. So K0, L0. Let's go side by side to help visualize this better. So if K plus J, right? So if our row plus our offset, J is the offset. That's what this is. J represents the offset. So our first offset is 0. If K plus 0, or 0, 0 offset, our modulos number, which is 3, the length of our ship that we're trying to track down, equals our column divided by modulos number. Then it's a one that we want to hit right off the bat. We got 0, 0, right? So let's say we are on 1, 1. 1 plus 0 modulos 3 is a remainder of 1. 1 modulos 3 is also a remainder of 1. We want to target it again. And how would that look for something like this? We got 0, 1, 2, 3, 4, 5, 5 and 2. 5 modulos 3 is going to be 2. And 2 modulos 3 is obviously also going to be 2. Down here we have 1, 2, 3, 4, 5, and this will be 8. So 5 modulos 3 is going to be 2, and 8 modulos 3 is also going to be 2. That's how we know we need to hit it. And if we are on an offset, it's the same thing, but we're just moving 1 over. So once we've established it's one we want to hit, let's hit that X and let's inverse our number in our mirror list. So right, if we're on the index of 9, we are going to return the first index, or the index of 0. And we want to make it a hit. We filled out our maps, and we're ready to move to the next offset. Now, once it does this for all 4 pages, our map book is complete. Now, of course, we could do that just by declaring the X and the O's instead of that big, long, complicated formula, but I promise you, it is a whole lot longer. We have 297 pages of every single one of those maps that we just declared. If we stop here, we see we're on the offset of 5, and we're just going down. You will also notice this regenerate our targeting board. So we're going to update our targeting board as we sync the ships. That is how we know we are still using the most efficient method. So what it's going to do first is find the zones. If you take a look at this, the grays are the hits or the ships, right? So maybe this was a 3 long battleship. This was a 5 long. Maybe this is a 2 long here. These are our separate zones. You notice they don't connect. So each zone could have its own best efficient map. So if we take a look at the left-hand zone that you just saw, all these different maps for finding every third could fit inside of it. And one of these is more efficient than the other. So first it's going to go through that map book and try each zone and see how many of these red valid hits are located inside of this zone. So some of these will have more valid hits than others. We have 18, 17, 17, I believe. And then we have 15. So no ship that's 3 long can fit inside of any of these gaps inside of this left-hand zone. So this is going to be the hit sequence that gets assigned to this zone. So first we find our zones, assign it to the array, then we're going to go through that zone array and run through those best maps that I just told you about. Once it finds the best map for the zone, it's going to adjust our target map. So it'll adjust to find that best zone, reassign it, and it'll no longer look like this once ships start sinking. Finally, we have our targeting system. We're going to start just by having a random target because we don't have any data to go off of to start with. So we'll just pick a random data, check if it marks one of those X's on that targeting map, right? If it doesn't have an X, it's going to go through the loop until we find one that's both an X and hasn't been hit yet on the board. So we're checking our targeting map and the current state of the board to see if it's been hit and if it's one that we want to hit. Once we found an XY coordinate, we're going to return that target. Or rather, we're going to assign it and then return it. But what if we've already hit a ship? Well, then we need to retarget that ship. Now, we may know whether or not it's horizontal or not based on the gap that it's fitting in, or if it's the third or fourth shot, then we're already going to know if it's horizontal or vertical. But if we have one shot, maybe it fits in only one gap and it can't go any other way, but maybe it does. Maybe it goes both ways, in which case we're just going to shoot randomly. We're going to pick a number 1 through 4 and just go up, right, left, or down. As long as the ship can fit in the gap and we're not out of bounds, we're going to return that coordinate. Otherwise, maybe we are out of bounds, in which case we're going to turn around and just go the other direction. So we're going to use check fit to see if that ship can fit in that particular coordinate, if it's a good choice. If not, we'll just choose another direction. So let's take a look at everything in action. I'm going to speed everything up through the boring parts. I'm only going to slow it down when the targeting map changes, which is when we're going to start hitting the ships.